Well, I'm the last presentation of the whole Smart Manufacturing series here, and end of the day. So, but mind you, it's a long day, it goes to 8 o'clock tonight, so you got lots of things to do and deal with. But I think we've got a very exciting topic. You've heard from, if those of you who were at some of the earlier presentations, a lot of discussion about visibility of information, visibility about what's going on the shop floor. Work instructions are very good, human resources, teaching what's happening, information about what's going on in the machines and the shop floor. That's what it's all about. Smart manufacturing is all about the data in terms of what's happening. And there's some significant benefits in terms of what can happen there. And I'm going to share that with you today as we go forward in terms of our presentation. So from an agenda perspective, I've got a number of particular topics to cover and work through. What makes a top shop? I'll share with you some of those things, some of the data streams, visibility as I mentioned, IoT, what is it? There's lots of issues surrounding that, pragmatic approaches to business, and certainly some of the specific examples and benefits that we can achieve and do. If we look at what makes a top shop, and this data comes from Modern Machine Shops. Modern Machine Shops does a survey of all kinds of, I think it's something like about 3,000 shops throughout North America, and then compiles the data and really does a lot of benchmarking. And it's a significant survey that is used in a lot of the manufacturing environments. But what they've found is the top shops, and that's the top 20% of machine shops, tend to end up being about twice as better as anybody else. That's twice as better in sales per machine, twice as better in terms of profitability, twice as better in sales per employee. So these are numbers that come together. So what are the characteristics about make that happen? Well, the best are doing all kinds of operational refinement, strategic deployment, sales areas, but really applying themselves better in the right sorts of way. And one of the things that's a common theme we see is that they're using data in the right way to make solid operational decisions. So it's part of data-driven manufacturing. So the top quartile are really doing continuous improvement, 55% of them. Lights out manufacturing, value stream mapping, internal training programs, benchmarking in terms of their operations. Again, all this takes data to make it work, and if you want to be a very successful, efficient shop, that's the type of things you would actually work for and deal with it. So what are the type of data streams that can come together from a manufacturing type of environment? Well, really there are many data streams, and it's really the ubiquitous drive for connectivity in terms of what's out there. There was a statistic a number of years back that AMT put out that 97% of manufacturing machines were not connected to any network. That means there was no visibility about what was going on with those machines. And I'm sure it's well over 90% today, just judging by what we can see that's there. So it's all about having the information, customers, suppliers, shop floor, management. I've got customers today that have web portals that can access, their customers access the web portal, obviously secure login, key in a particular work order number and find the exact status, real time, about which machines it's running and when it's going to be completed by. The technology is here today to do that, and we enable that technology, and again, we're going to show you and share you how that all comes together. Part of this is what makes the data available. There are hardware components out, I/O devices that you can connect to machines, especially older legacy machines that have no Ethernet or no, maybe not even any serial cables and so on. Some of the hardware devices can pull out signals and actually enable them to be now MT Connect compliant, industry standard code, communicate, and be able to take that machine and be widely available for use in terms of your overall networks and deployment. Examples of connections, these particular boards get installed right into the back plane of the machine. So right inside the control cabinet, picking up signals like in cycle, e-stop, alarm, part counts, various different signals directly from the machine, and then translating that so that it can be used and therefore represented. And so now you have visibility about what's going on in the overall environment. But there really are three data streams that come together here. There's the traditional approach, which is operator-centric. Traveler comes along to the machine, work center, the operator barcode scans the traveler, goes into the ERP system, says, okay, now I'm tracking what's going on with the machine. But he doesn't know anything about what's happening in the real-time world of the machine cutting. If the machine stops, it gets into an M01 as an optional stop to wait, or if there's an alarm and that sort of stuff. None of that is tracked in the ERP system. But the operator has done some interaction, maybe even written on a clipboard. That clipboard has then been translated into an Excel spreadsheet and then displayed a couple of days later. So The operator-centric is the old approach to dealing with them. In fact, barcode scanning is an old approach when you take that area. There's the automated centric approach, which is working directly with the machines and tying everything together. So you have operator data, you have business systems data from your ERP environment, and then you have machine data that comes together in terms of tying it all together. So it's that whole machine data, tying these different data streams together, that gives a lot of power for data-driven manufacturing. So you move from reactive information from the operator environment to proactive alerts generated from the machine. If the machine gets a temperature spike or for some type of spindle or whatever, then you want to be alerted that there's a problem happening before it happens, because that can be an expensive crash if things break down. So these types of things are where really IoT and data-driven manufacturing makes a huge difference going forward. Business systems integration. Take your ERP systems, Sightline or SAP or whatever it may be in terms of various different ones that are out there. You want to tie that together in terms of manufacturing data bisynchronously, take work orders directly from the ERP system, load them into the execution system on the shop floor, and send the results back up to the ERP system. So you can import all this particular data, put it into the MAS environment, track the progress in real time, at end of job, end of shift, have that actual information. And the benefits start to be very important in terms of minimizing work in progress, eliminating errors, visibility with what's happening. But if you have accurate run times, that helps in regards to your product standards, which then means your costing can be accurate and it means your scheduling can be accurate. But that'll be based upon real-time work and collection, which you can put together with business systems integrations. If we look at the factory of the future and take it from a general perspective, there's a number of particular ways to look at things where you can really work with evidence-based data. That's a big thing in manufacturing. A lot of manufacturing today is run by seat of the pants, gut feel. Plant manager says, well, I'm pretty sure that's the way it works, or some operator says, I know I can tune the machine myself, and they just make gut feel type decisions. Well, when you start to get to data, and you can actually analyze this and then get into charts and details, then you make much better decisions about actually running the plant in itself. You get work order scheduling results, connecting to your ERP systems for accurate accounting, work in progress, inventory management issues, driving cost out of the overall environment, process improvement, benchmark, really just understanding what's happening. There's a lot of little things here. And what I like to say is there's a horizontal and vertical integration that can happen with data-driven manufacturing. And what that means is the vertical integration is essentially shop floor to top floor. It's a tagline we use where you start from the ERP systems, drop it right down to the machines, collect all the data and send it back up. So you've got a vertical integration about what's happening across the company. The horizontal integration is being able to communicate to all the shop floor people. If the operator says the machine is particularly down, I need materials, he hits a particular button, and the guide in materials sends the materials over. I got a programming help. He hits a button, says programming, come to help him get the machine done. Or QA first off checking, come immediately to help out. Or big screen TVs that are across the shop floor so people see what's actually going on, statuses. Reports being sent out automatically to everybody about the status of particular jobs and running and schedules for the day. All these things can happen across the shop floor. So that horizontal integration means everyone sharing of information. I have a particular example. One of our customers, speaker was in front of me before this presentation, where their operators actually were absolutely satisfied with a solution about being able to have a communication across the shop floor. Because before there was that type of communication in place, it was mayhem of all these people running around the shop floor trying to figure out what was working and what wasn't. Now they didn't have to worry about it because they knew they could see it all on the network. So there's huge advantages of just sharing that information. So it's visibility, as I mentioned right in the very beginning. So let's take a look at some examples of what that means. Operator on the shop floor, you can look at data that's captured in real time, sent to management. You can increase machine operator awareness about what he's working on, what's actually happening, defines how the manufacturers can generate revenue and growth. I mean, you can get to the point now, you can even put financial numbers associated with particular production so you know whether you're making money or not making money. Again, it's the amount of data that you're willing to make available and share and so on. But you can also look at Gemba boards and on screens. This particular customer is working with reports that are all printed out, in terms of metrics on a daily basis, but also and on screen so people can see the metrics and then judge from that and again, share that across the screens. So it becomes common and objective data right across the entire factory floor. The objective data is actually a very interesting point because a lot of operators, a lot of people don't like dealing with the gut feel type of decisions. But now when you've got objective data, people are looking at that, I guess that's what's happening. Okay, let's do things. And if you're also dealing with benchmarking data where you say, hey, you know what, let's run a benchmark. Last week, this is what we did. This week, this is what we did. And the only change we did was this. I guess that's a good change. But now it's objective and it's not subjective type of efforts. So the other ironical thing is you put in big screens and you're showing real-time data about what's happening on the shop floor. You'll typically get a 6 to 10% improvement in efficiency just because everyone knows, whoops, we're watching things, everything's monitored, we can see things. So that increase in efficiency starts to happen just by that awareness that's there. But frankly, to be frank, most operators and most manufacturing plants want to be efficient. They just need to be pointed out how and where it works together. And that's where your objective data comes into play. But it's transparent, accurate, and timely information really delivered to the entire operational management team so everyone knows what they're working on and sharing with it. So some particular examples, these are pictures. This one made me laugh. That's a 70-inch TV on top of every Mazak machine that they've got. I think it's overkill because you could just take a big screen and put it in one particular place. But this actual workstation, it comes from a plant manager, and he sent me that particular picture because that's how he literally runs his operations. And it's all real-time information, color-coded for this plant and the machines, the status, metrics of what he's running. He can look at that and he knows if it's all green, things are running right. If he starts to see the color changes, he goes out on the shop floor to figure out what's going on. So it's, you know, just having the information widely available and working with it. This particular one shows a big screen, sort of dashboards, event management, and so on. But this other one on the bottom is also an operator portal. So the operator has information about his workstation, his particular machine, the parts he's going to be producing, expected delivery dates, expected timing. All that stuff is coming available so that he can actually be more efficient in terms of his manufacturing. Some examples, pictures worth 1,000 words, tracking metrics and the speedometers here, various different machines. Now all types of numbers associated with parts produced, quality, rejects, expected delivery dates and timings. All that stuff can come together and they can be color coded to make sure that you can see easily, visually what's happening. Just one way of looking at data. Another particular way, a few less machines, overall metrics, graphic charts to plot if that works for you. People are very visual oriented in a lot of cases, so it's good to have the visual capabilities and also be flexible and tailoring to take that information to use it in the right sorts of way. If you want to get into detail of machines, now you can break it down on one individual machine and say, okay, this is the amount of information that we need to work with and deal with, and there is an immense amount of information on each individual machine in terms of statuses, and present that and work with it. Another particular area, this is an event chart is a kind of a very neat, and we found is probably the most important chart, especially for continuous improvement managers, because if everything's green, you know it's running right. But if you can see colors and blocks of colors, you're going like, wait a second, what's the root cause for those blocks of colors? If I can clean that up, I can get more efficiencies. So, and you have, of course, the historical data to go back and track it and understand it. It's not a question of asking the operator or looking at some Excel spreadsheet or some set of charts after the fact. You got a visual right in front of you. So, IoT, Industrial Internet of Things. What's the fuss about? What are we dealing with in this type of area? It's a huge market, you know, trillions of dollars according to whoever you're dealing with. It's also about machine to machine, and frankly, probably there's more machine data out in the manufacturing shop floor than anywhere else that's happening. So it's all a question of utilizing that and utilizing it in the right way. A bit of history, if you don't know about IoT sort of area, it really is the fourth industrial revolution. The first one was mechanization, the second one was mass production lines, third one in the 20th century was really computerization and NCs and so on. The former president of the Association for Manufacturing Technology of the US, John Bird, made a major statement that what the NC machine did to manufacturing in the 20th century, data-driven manufacturing is going to have that same effect in the 21st century, which really takes it into another industrial revolution, or an order of magnitude faster or improvement, which is why it's called Industry 4.0 or IoT and Industrial Internet of Things. So what is the Industrial Internet of Things? If we look at it from our perspective, it's collecting data on the shop floor. MT Connect been a fabulous boon to manufacturing, to getting in industry standards for common communication. There are various other protocols out there, OPC, FANUC Focus, and many other protocols that are available. There's also hardware adapters for I/O collection from machines, but that's all about that last meter connection to the machine. Most important is that last meter. How do you get to those signals? All kinds of software out there, but if you can't get to the signals, the software's not going to be worthwhile for you. And then it's a matter of tying in your business systems with ERP, tying in the operator information. So it's really what we call operator or OT and IT, tying it all together, operational information and information technology. What does it mean to you in terms of manufacturers? You can really take huge advantage for IoT in terms of the technology. It can mean competitive advantage for you. Applying it to your particular business areas where it makes sense and getting the right information to put things together. Really can collect and analyze data and manufacturing streams and come together with all kinds of new ideas and thoughts about how operations really run. And connect machines for actionable information. So that's really the issue, is take that visibility and create action on it to work in the right sorts of way. I also liken it to really a technological shift. And we've seen in certainly the IT world many shifts over the decades, from time sharing and PCs and internet technology, and really we're into the now universal machine connectivity with IoT. All this stuff has come together to accelerate the technology we're seeing and working with. So if we take a look at what is IoT, started with the Internet of Things, add Industry 4.0, it's certainly proliferated over in Europe and so on. Add the industrial component to manufacturing and it becomes Industrial Internet of Things. All these things really are the same thing. It's a convergence of the same type of applications into what we call data-driven manufacturing. And really what data-driven manufacturing is all about: consolidated reporting, big data analytics, it's corporate dashboards, it's real-time information, and it's really tying everything together in terms of all the data. So it's, again, using that information and putting it together in the right way. It is non-trivial in terms of a lot of aspects, in the sense of you got to start with data at the machine, and that data, think of MT Connect and other protocols, is streaming data. Now you got to contextualize that data. What does that data really mean in a contextual aspect? And then once you contextualize that, then you've got to present it in visualization tools. And there are easy ways to be able to do that, and we've certainly solved that for the last few decades. We've been working on this type of area, so there's ways we can do that in a nice way. Whoops. And there are also myths associated with Internet of Things. There's a lot of myths about being very much a theoretical construct, being unquantifiable, being sort of unknowns in terms of all the machine-to-machine type of areas. But the reality is, it is a disruptive technology because it is a significant leap forward in terms of next industrial revolution. It's transformative in a good way, but it's also known and quantifiable paybacks. So you can eradicate productivity gaps, and frankly today you can get a 300% internal rate of return, typically 4 to 6 month payback on these type of implementations. They really have an effect in terms of the bottom line. And frankly, the reality is it's available today. So you walk around, all kinds of companies have this stuff and are using it and working with it. So I'm going to take it to another dimension of continuous improvement, and this is a very powerful particular point. It's fueled by real-time data. So this is what data-driven manufacturing is. So how do you apply the data now? And this is what continuous improvement's all about. There's the Deming circle. You go round and round in terms of find the bottlenecks and work it through. You can connect to any machine, old and new. You can monitor and assess all kinds of manufacturing productivity in real time. You can identify bottlenecks and constraints, which is the important part. You can analyze the causes for the root causes and then fix the particular problems, discover the hidden factory and really grow it. Put it in terms of numbers, it's not uncommon for a company to start off at 35 to 40% OEE and then get themselves into world class at 85% OEE. That's like doubling the size of your factory. And that means that you've got a huge hidden factory inside the factory. You just don't know where it is, but you need the data to find it. So these tools help. So if we look at the types of increases that we can work with, you can measurably improve profitability, real-time tracking, improve on-time delivery, improve quality, improve uptime, better root cause analysis by having the data to understand what's happening. These are all good things to help you really do better. But you can also decrease things like find bottlenecks faster, reduce unplanned downtime, reduce setup changes, minimize unproductive labor, eliminate manual data entry, reduce costs and waste. So there are a lot of benefits here. I'm also deliberate in showing this particular set of slides because one of the things we found, there is no one silver bullet, if you want, to data-driven manufacturing. It is a number of little things. If you get 2% improvement here, 1% improvement here, 5% improvement here, and then you do this over 10 particular items, you'll end up with 50% improvement in efficiency. So it's all the little things that add up, and it's understanding those little things and making them work. This is another interesting analysis of continuous improvement. The traditional Kaizen step is really a 7-step process, and it typically doesn't deal with any real-time data. So you look at making problems and collecting the data, determining root cause, analyzing them, testing the hypothesis, collect the manual data. There's a lot of time wasted in the traditional Kaizen process by manually collecting data. And whenever you have manual collection data, you also enter into data collection problems and accuracy and so on. But it's a manual effort that just doesn't make sense. Really, what you can do now with IoT and the data-driven technologies available today is you can start to make it much more efficient by the emphasis shifts to the value-added activities that make sense and let the data do the data analysis and present you with the opportunities. Very simple little things like Pareto charts. And you're running a downtime report for the last week or the last month, and a Pareto chart comes up and says, geez, we're spending a lot of time in this particular state. I didn't realize that. Let's see what we can do to fix that out. And that's just visualization quickly, analytics, tying everything together that you can actually work with it. So easily develop solutions, implement the solutions, and make it work. So the whole process here with Kaizens really has a huge benefit in terms of understanding the issue, but it takes data to be driven to make sure you can apply it. So look at some examples, post-implementations. This comes from some customers of ours where they had their runtime increased by 45%, and they actually saw their QA and setup time decrease by 72%. So these are significant benefits when you start to apply it, and these are measured out over time. One of the things about data-driven manufacturing, you can benchmark. You can say, okay, here's the as-is type of model. Now let's make a bunch of changes. Let's say 2 months or 6 months out, what are the changes? What's the effect? And you'll see significant trend lines, and you'll see significant operations that flows right down to the profitability and the bottom line of the company. This particular example comes from another customer where they had a 90% improvement in OEE, and they tracked it out over 6 months, and the way they were able to get some huge benefits just by understanding what they're working with. So what are some of the areas to explore in regards to overall equipment effectiveness? Well, there's rising business costs, data collection accuracy, and integration, productivity, and really it's all about asset utilization. In fact, if you track down to most investments in manufacturing machines and background, it's all about maximizing the asset utilization. I've heard terms about sweat the assets before buying any new particular machines. I've seen machines being purchased and put on machine monitoring systems just so they can, as an insurance policy, to make sure the machine actually achieves the rated specification that the manufacturer was selling them on. So there's huge benefits of having the data, but making sure that you get the maximum utilization of that particular asset. Why does OEE matter in the world today? Well, OEE is actually the most important metric in manufacturing because it combines together your quality, performance, and your efficiencies. And world-class OEE is typically 85%. Surprisingly few companies are at that level, but a lot of times it's just because you don't necessarily understand the data and what's happening with the machines. So critical metric, availability, quality, and performance really ties all three things together. And I think most people probably are aware, certainly, of OEE in terms of what it does. But if you look at it, it can replace manual and subjective with the automatic and objective data collection type of areas. True visibility. One of my customers said, well, we're shining a light out in the corner of our particular plant because we just don't see what's going on out there. So it's really a true visibility type of area. The opportunity can take manufacturing really to the next level and really reveal your overall hidden factory. So what are some of the roadblocks and what do you want to look out for as you go down this particular journey? Well, the traditional approach to IoT is let's focus on the technology of the how. Let's see what we can apply it to, when we can do it, and why the business should be. Well, that's really kind of a bit of upside down. You're focusing on technology at that side, not focusing on the business. We believe in turning it upside down. Focus on the business case first. Why would you do this? What does it mean to you from competitive advantage? What does it mean to you from your product quality and your production throughput in terms of timings? And take those particular business reasons why and say, okay, now we're going to implement what we can do, when, what, and how we're going to get it done. The important part about how, and one of the messages I hope we share with you today and leave with you, is that it is available today. This technology is available and proven, and you can use it. It's not a development project, it's not an IT project, it's an application to your business type of project. So the why is focus on the business case, look at your competitive advantage, look at the change in culture of the company, look at the what we see very often in manufacturing is the tyranny of the immediate. People are too busy trying to get their daily job done to worry about strategic direction of new particular products and efforts. But it's important. You've got to do the bigger issues. There's certainly the whole fear, uncertainty, and doubt aspects with a lot of these things. Failure, data system security, unknowns and changes. You have uncertainty in terms of what's the path forward and quantifiable results. Doubt in terms of promised business outcome, what types of required changes happen. All this can slow these projects down. And if it slows a project down, what is it? You've got analysis by paralysis type of problem. And you're in a situation where you're not getting things done. And that's where executives have to make strong decisions to apply it and move forward. So inaction really becomes a lost opportunity cost. I have customers of ours, which I'm really impressed with, some of the CEOs of companies, little public companies, global operations, drive OE metrics across all their particular plants. And there's so many things involved with this, it's amazing to think of. But if you have a culture driven from the CEO of efficiency and OE metrics, that's going to flow down to every particular operator, every particular plant manager, all the machines, everyone in the organization. Efficiency, efficiency, efficiency. That's just a culture change because the CEO is driving this stuff. But also, when he starts to get the data together and says, okay, this plant is performing at this level, this plant's performing at this level, what's the root cause for that? Oh, you know what, I'm going to shift production from one to the other. I can balance load in terms of production and operations. Now he's down to machines, he's down to production in terms of product, and then he can also assess, whether machines are performing properly and right. Huge benefits operationally, huge benefits culturally, and it all translates to a culture of wanting to be efficient. I recognize not everyone thinks the same way in terms of manufacturing companies, but this is just a good example of one. So specific examples with real numbers, we typically see a lot of implementations start in the 30 to 40% OEE type of level, but can very easily get up to the 85% world-class level. And this is a traditional sort of chart and efforts. Really, there are 5 big losses if you break it down through continuous improvement and lean techniques and efforts. It gets into maintenance, setup, downtime, small stops, and speed losses. Just about everything can be classified in those types of areas. Yeah, you'll have other reason codes based upon your machines and operations. But if you can break those 5 down and understand the root cause of all 5 of those and then fine-tune that, that's how you get your productive time up to be the maximum sorts of level. So the value proposition, as I mentioned earlier, it comes through many different things. I saw a study from IDC quite recently that actually classified in IoT areas for manufacturing 9 particular areas, all of which stood to gain potential improvements. And their analysis is most manufacturers would stand to gain about a 57% improvement in efficiency. And that's an independent research group that's dealing with it. But what impressed me is they actually broke it down to the similar sorts of things that we're seeing here. Because it's at 2% here, 3% here, it all adds up to a significant productivity gain that you can work with. So if I take an example, a medium-sized manufacturer with 30 machines running 5 days a week, 16 hours a day, say an $85 an hour fully burdened cost for the machines, which by the way is actually inexpensive. Modern Machine Shop actually says the average in the US is 125 US. I've seen companies talk in the $160, $170 an hour burden rate for their machines. So you'd apply whatever works for you. These ROI calculators are generally available. 30 machines, and apply, say, in this particular case, an 8% overall equipment effectiveness improvement in efficiency. you're going to end up with about $2.5 million in the savings over the 3-year period. Your project payback time would be about 3 months, IRR on capital about 400%. So really you get some significant savings in terms of dollars. And this is just a small, medium manufacturer of 30 machines. You scale that up with more machines and efforts, it really has some big examples that you can apply it to. So some additional transformative benefits that you can look at. Company, precision machining company we work with, 25% savings on the whole plant sort of effort. I've had companies go from 40% OEE to 82% OEE. That's over 100% improvement. I had Magellan Aerospace in Kitchener, Ontario with us. They had 130% improvement. They went from 37.9% OEE, and then in a matter of 3 to 4 months, they were able to get it up to 85% world class. So these things are actually attributable, and they actually published the results, so it's an interesting example. But even going from 24 to 62% OEE, that's a significant gain in terms of effort, because it's not the raw number, it's the delta number that gives you a percentage. So many other particular examples, Palatex systems, when you break it down to individual areas, 140% improvements, 40% gains on Mazax. I had a particular customer in Chicago, largest manufacturing plant in the city of Chicago, S&C Electric, and they came up to me and they told me many different benefits and different things, but one of the things they found was just somewhat ironical. They kept watching this one machine, first thing in the morning, 10 o'clock, 10:30, the machine still wasn't running. Then I kept asking the operator, why isn't the machine not running? Oh, no, the machine's running. I know it's running. It's all doing this sorts of stuff. Eventually, they confronted him and said, no, it's not running. Take a look at it. Let's walk over to the machine. Walked over to the machine, and it wasn't running. The operator had no idea that other people could see what was going on. But that behavior started to change very quickly once people started to realize that you can't start to fool people in terms of the operations. So many specific benefits that you can apply. Really, to summarize here, the IoT is being applied successfully in manufacturing today, so you can really work with it. Your paybacks are typically 4 months time frame, 300% IRR. The path is well known. These technologies can be applied. The benefits are extremely compelling. The why should always be the first discussion point. Address the business case to make it work. It can be cost effective. The last meter problem has been solved, and you've heard from all kinds of technologies, and empty connect and that sort of stuff really solves that. Data can be effectively collected from all types of manufacturing equipment. Metrics help in terms of analyzing data. Internet security is a very big issue, but that's also solved and can be applied. So really the benefits are here and can be worked with. So I'll take any questions at this point, and hopefully this was helpful for everyone that you're working with. No questions? I've answered everything at the end of the day? We're too tired, falling asleep? Certainly, we're at booth 1266. Our system is on demonstration presentation, so we can share with you and show you exactly how it's working and what it can do. So, good. Thank you.